So we've seen standard form, we've seen vertex form, and now we're looking at the final one, intercept form. Intercept form is just another way that we represent quadratics where things are actually kind of already factored out for us, and we can kind of graph that using our factors. So a just represents some number, some kind of constant that's being multiplied by our factors. P and Q are actually just some other numbers themselves, and those actually represent our zeros. So those x-intercepts, in other words, the same thing as zeros, are going to be P, so some x value P, comma 0. Our y value will always be 0 there. And again, our Q coming from our other factor, comma 0. So those x-intercepts are going to be P and Q, just coming in from our intercept form. Now, the axis of symmetry, which is also tied to the vertex, are always halfway between these 2 points, and we'll talk about why. So as a result, though, to try and figure out what is that vertex, it's going to be P plus Q divided by 2. So in other words, it's just the average between these 2 points. So let's actually kind of see this intercept form in action with some regular numbers. Example 4 says that we're asked to graph this intercept form. Well, right away, our x-intercepts are literally just the opposite of those numbers dropped in parentheses. So we have, since it's x minus 1, we just have positive 1. And then our y value is always 0. For our other x-intercept, we're just taking the opposite of this guy. So negative 5, comma, and then our y value again, always for x-intercepts, 0. And the reason for our y values always being 0 there is we're trying to figure out where is it crossing this x-axis. That's why they're called x-intercepts, much like we saw with the y-intercept. So the y values, if it's crossing this axis, because they're not moving up or down any, are always going to be 0. Now, again, we'll talk about why it's the opposite later on in this chapter, but for right now we're just focusing on the graphing. So we have 1 comma 0 and negative 5 comma 0. So there are our 2 x-intercepts. Now we're trying to determine where is in fact our vertex. Well, the reason why our vertex happens halfway between these 2 points is because it still follows that vertex showing the axis of symmetry, which has that mirror. So you may recall back from like when we were looking at vertex form and standard form, the vertex always created your mirrors. And if in fact the mirror is halfway between these 2 points, we would see that the left side then is the same exact as the right side. So that's why we're looking and trying to see where is that vertex when it's halfway between these 2 points. So in order to find that vertex, we're going to take our P plus our Q. So 1 plus our Q, negative 5. Add those together and divide by 2. This again is going to give us our x value. So 1 plus negative 5 comes out to be negative 4 divided by 2. So x comes out to be negative 2. So our x value, again, is negative 2. This is where we're going to see our mirror. And even just looking at our graph, we can see that the mirror is kind of making sense that it's at negative 2 because the left side is kind of matching the right side. Even you could actually just go ahead and like look at your points and see halfway between that would be negative 3. Or I'm sorry, negative 2 rather. Negative 2. So we know our x value, but we have no idea yet what is our y value. But that's not so bad. All you really have to do is to determine the y value, just plug in our vertex x value, which we know is negative 2 in for x. So to find y, we have y is equal to 3 times, it's no longer x, we know that it's negative 2, minus 1, times, instead of x, we know it's negative 2, plus 5. And now we're just kind of simplifying this out. So then y is equal to 3 times negative 2 minus 1 is negative 3. and then negative 2 plus 5 comes out to be positive 3. So it looks like our y value comes out to be 3 times negative 3 times 3. So it looks like negative 27. So negative 27. Just exaggerating this a little bit, let's just say that the y's are going by 3s. So negative 27 would be represented right about here. So again, our vertex is happening at negative 2, comma, negative 27. And as a result, the axis of symmetry is identically to how we found them in the past. So it's just x equals negative 2. Now talking about the y-intercept, the game is still exactly the same. You're still going to throw in 0 for x because you're trying to see where is it in fact crossing this y-axis. Well, we're not moving left or right any for x. That's why it's going to be 0 for x. We're going to throw in 0 for x and see where is it crossing, what y value is it crossing for. So we don't know what y is, but we do know what our x value is. It comes out to be 0 minus 1 times 0 plus 5. So y is equal to 3 times 0 minus 1 is negative 1. 0 plus 5 comes out to be positive 5. So now we have 3 times negative 1 times positive 5. So that comes out to be negative 15. So for our y-intercept, again, we threw in 0 for x, and we ended up with a y value negative 15. So we have 0, again going by 3s, so we'd have to go down 5 to get that y-intercept. So 1, 2, 3, 4, 5 to get that negative 15 value. Now again, because we are 2 units to the right of our mirror, we would have to go 2 units to the left of our mirror, and then that other point would come out to be negative 4, negative 15. And again, the reason why it's negative 4, negative 15 is just the scales. So our x, we're always going by 1s, whereas our y's, we're going by 3s. So it's not directly proportional like with the x's and y's. So just keep in mind that that's why we have negative 15 there, that reflection point. All we have to do now is connect the dots, and we're good. So more or less, we would see a parabola doing something like that. So again, in intercept form, we actually already have our intercepts given to us. To find the vertex requires a little bit more work. We actually have to find the average between the two, and that gives us your x value, also your axis of symmetry. Then to find out what that y value is for the vertex, you just plug it into the function and see what it comes out to be. For the y-intercept, just as always, you throw in 0 for x, see what the y comes out, and then you just mirror it with the reflection to find your reflection point. But again, that is example 4 from our 4.2 set of notes.